So, when we're talking about the electrolysis of brine water is a mixture of sodium chloride and water. If we want to go and look at the half equations, water will break down into hydrogen and a hydroxide ion, so OH-. The hydrogen ion, because it's got a positive charge, needs to gain an electron to become hydrogen atom. The hydroxide, because it's got a negative charge, will need to go and lose an electron to become a hydroxide. Right, in the same way, our sodium, because it's got a positive charge, will need to gain an electron if needs be. And the half equation for the chlorine will need to lose an electron. So when we're talking about specifically the electrolysis of brine, the first real thing that we need to go and talk about is the fact that we're adding brine water, right? Remember, brine water is a mixture of sodium chloride and water. It's got to be relatively concentrated. We then go and put an electric current through it. As we put an electric current through it, that splits up the sodium chloride and it splits up the water. The sodium chloride goes and forms chlorine ions and sodium ions. The water goes and forms positive hydrogen ions and negative hydroxide ions. Remember that whenever we're talking about electrolysis, opposites attract. So, the chlorine, because it's got a negative charge, will go and move towards the positive electrode. At that positive electrode, they'll lose an electron and form chlorine gas. The hydrogen, because it has a positive charge, will move towards the negative electrode where it will gain an electron, therefore becoming hydrogen gas that will go and bubble off and can be collected. So that leaves in solution our hydroxide ions and our sodium ions, which will go and combine together to form sodium hydroxide. The sodium will never go and form actual metal because sodium is really reactive and it would react as soon as it formed actual sodium ions. So the three things that we make during electrolysis of brine water is chlorine gas, hydrogen gas and sodium hydroxide.